relationships. So we're going to start with this theorem that if two chords intersect in the interior of a circle, then the products of the lengths of the segments are equal. Okay, so when it's saying that it's intersecting in the circle, we can see that here. It says the products of the lengths of the segments. Okay, so what you would be multiplying together is this segment times this segment. Okay, and you would be multiplying BE by AE. Okay, so that's what it's showing you, is that we're multiplying those together. So I'm color coding them so you can see how this is going to work. Okay, so we're going to multiply AE by EB, and that's going to be equal to CE times ED. You can think of it as the circle's way of cross multiplying. Okay, so the intersection breaks it up into two segments. So then what we're doing is we're finding the product of one segment, and that's going to be equal to the product of the other chord's segments. So we're going to apply the chord-chord product theorem, which is what that is called. Chord-chord product theorem. Okay, and for example 1, it says to find the value of x and the length of each chord. So not only are we going to find out what x is, then we have to go back and find the length of each chord. So let's go ahead and use our theorem. So what we can do is we can multiply FJ times JE, we can multiply those lengths together, and that's going to equal the length of GJ times JH. Okay, so FJ has the length of 7, JE has the length of 10, GJ has the length of 14, JH has the length of X. Okay, so 70 equals 14x is really what you'll be setting up. Okay, and then does 14 go into 70 evenly? Yeah. Yep, what is it? 5. Now, that's the first part, right? We found the value of x, so we did that. Now we have to find the length of each chord. So the first chord is FE. Okay, that's the entire chord. So FE is going to be 10 plus 7, or 17, which you can see right on there. Okay, and then for GH, okay, the length of that chord is going to be 14 plus x, so 14 plus 5, which is going to be 19. Okay, so remember, it's the products that are equal, and it's not the lengths of the chords that are equal. Okay, so it's the product of the segments that we know are equal. All right, and then let's flip it over. Okay, so we had the chord, now we have the secant. We like to repeat ourselves, don't we? Okay, so this says if two secants intersect in the interior of the circle, then the product of the lengths of one secant segment and its external segment is equal to the product of the lengths of the other secant segment and its external segment. Okay, so let's see what this looks like. And again, we'll do some color coding. Okay, so the first one we're going to look at is AE. So AE is the length of that entire secant. Okay, BE, how would we describe where BE is? on the outside. Okay, so AE is the length of the segment, or we'll say the length of the secant. Okay, and then BE is the exterior segment of the secant, or secant. Okay, and then the other one, CE, is the length of the second secant, and then DE is the exterior segment of the other secant line. Okay, so for example 3, we're going to apply this product theorem. Okay, and let's look at our two secant lines. Okay, so we always want to multiply the length of the total secant. So here, see how this one has all numbers? We'll do this one first. Okay, so it's the length of DE multiplied by the length of the outside segment. Okay, so the length of DE is what? 16. So first I'm just going to write DE times 7. So the length of DE, which we get by adding 9 plus 7, is what? 16. So 16 times 7 is equal to, and then on the other side, we want the length of GE, and we'll talk about how we're going to write that in a second. And that's going to be multiplied by the outside segment, which is 8. Okay, so GE, how are we going to write what that length is? Okay, so it has to be x plus 8, not 8x. Because if you're finding the length, then you're going to be adding them together. Okay, so that length is x plus 8. Okay, not 8x. Okay, so then this is going to be x plus 8 multiplied by 8. Which this is a binomial is what it's called when you have two terms. So you're going to have to distribute to both of the terms. So when you distribute, you have to multiply both of these by 8. So this would be 8x plus 64. And then 16 times 7 is going to be 112. And then this is another one where first we're going to find the value of x, and then we're going to find the length of each secant line. Okay, so when we subtract 64 from 48, when we subtract 64 from 112, what do we get? 48, which is what I said there. Okay, and then we're going to divide each side by 8, which is going to mean our x value is 6. So that's the first thing we had to find was the value of x, and now we're going to find the length of each secant segment. Okay, so the first thing we're going to find is DE, but we already know DE. What's that? DE is going to be 16 still, right? 9 plus 7. And then GE is x plus 8, so 6 plus 8, because that's what we just found for x. And that would be 14. So those would be our solutions as well. Okay, so for your homework tonight, you're going to have a mixture of some problems from last night's section and then some from tonight's section. So from last night's section, you're going to do 5 through 10, and then 20 through 25. And then for tonight's, you're going to do 2 through 4, 6 through 8, 12 through 14, 16 and 17. is